Space is full of mysteries. One could go on endlessly planning a mission, conducting calculations, trying to predict the possible course of the mission. But then you launch a spacecraft into the depths of space, and the spacecraft, or some of its instruments, encounter some anomaly. And it's not always a bad thing. Often, on the contrary, an unexpected event, anomalous readings from instruments, or strange behavior of the spacecraft can lead to new discoveries. This can even happen in situations where it seems like something on the spacecraft has simply stopped working. What if the instrument didn't just break down because of a defect, but was shut down by something in space that we don't yet know about? Interestingly, one of the first major experimental discoveries of the space age was made precisely in this manner. On October 4, 1957, the Soviet Union launched the world's first artificial Earth satellite, Sputnik 1. A few months later, on January 31, 1958, the United States launched their first satellite. The spacecraft was called Explorer 1, and it included a Geiger counter. Even back then, scientists knew that space contained some sort of radiation, and some measurements had already been made using rockets and high-altitude balloons. It was believed that the source of radiation was cosmic rays, including those coming from beyond the solar system. It was expected that as the spacecraft moved farther from Earth, the Geiger counter readings should increase. And that's exactly what happened. At lower altitudes, the counter behaved as expected, showing values consistent with predictions. But then, upon reaching a certain altitude, the counter fell silent. Or rather, it started showing zero readings, as if suddenly all the cosmic radiation had disappeared, which of course shouldn't have been the case. But it turned out that everything was actually the complete opposite. By analyzing the data from Explorer 1 and a little later from Explorer 3, James Van Allen, who had designed the instruments on these spacecraft. Many of you probably already guessed where this is headed. In short, he concluded that zero readings were not because the radiation had disappeared, but rather because there was too much of it in certain areas around Earth. The particles were overwhelming the counter, and it couldn't give accurate readings. If the counter had been able to handle the particle flow, it would have shown radiation levels almost 1,000 times higher. This is how Van Allen radiation belts were discovered, regions around Earth where high-energy particles, mostly coming from the Sun, get trapped by Earth's magnetosphere. Understanding processes in near-Earth space is crucial for space exploration. After all, radiation can affect both humans and the operation of spacecraft, so the anomaly the spacecraft encountered led to an important discovery. But of course, this is far from the only example of anomalies we have encountered since the beginning of the space age. Today I want to talk about 3 such anomalies. Some of them have already been solved, but it took decades to resolve them, and some still remain a cosmic mystery. And the possible solutions to these mysteries are very diverse, from simple instrument malfunctions to yet unknown effects in deep space and even the need for new physics. I'm Andrei, and this is Cosmos Elementary. Perhaps one of the most famous anomalies which couldn't be solved for decades is the Pioneer Anomaly. Today, it is generally considered resolved, or at least there is a very convincing explanation that many agree with. Although, even after the publication of the final papers on this explanation, there were still those who insisted that the cause of the effect could still be new physics or our not entirely correct understanding of how gravity works. Interestingly, this effect was discovered specifically in the Pioneer 10 and 11 spacecraft. Despite the fact that they were launched in the early 1970s, some measurements that made this discovery possible were almost more accurate than those from many modern missions. But let's go through everything step by step. The Pioneers truly lived up to their name. The Pioneer program began at the dawn of the space age, back in 1958. Several missions within this program ended in failure. The first spacecraft that actually reached space became Pioneers 1 through 5. Pioneers 6 through 9 much more advanced spacecraft entered orbits around the Sun in the inner solar system and studied the Sun. But Pioneers 10 and 11 were the most pioneering of the pioneers. Pioneer 10 was launched on March 2, 1972, with a bunch of scientific instruments on board. And this spacecraft did many things for the first time in history. For example, it was the first to completely rely on a radioisotope thermoelectric generator to generate power. This will come up again later in our story. Before Pioneer 10, no man-made spacecraft had ever traveled farther than Mars. It was the first to not only cross this boundary, but also the first to enter a trajectory that would eventually take it beyond the solar system. It was the first to pass through the asteroid belt and the first to reach Jupiter. It was the first to cross Neptune's orbit and became the first man-made object to travel beyond the farthest major planet. During its flyby of Jupiter, the spacecraft captured images of the planet, details of its atmosphere that were not accessible from Earth at the time, and photographed the giant's moons. And throughout its mission, it gathered a huge amount of valuable data that led to a whole range of new discoveries. The sister spacecraft, Pioneer 11, was launched a little later on April 6, 1973. It also reached Jupiter, flying much closer to the planet, and it captured more detailed images and for the first time photographed Jupiter's polar regions. But it was also the first in history to reach Saturn. On September 1, 1979, he flew just 21,000 kilometers or 13,000 miles from the planet. Of course, it took pictures of the planet and its moons. It was certainly an interesting time, as just a little over a year later, Voyager 1 would fly past Saturn. Overall, both Pioneers were truly revolutionary spacecraft. They operated for decades instead of the planned 2 years. Contact with Pioneer 11 was lost in 1995 and with Pioneer 10 in 2003. For some time, they were the most distant man-made objects, although the Voyagers have since surpassed them. Even though there is no communication with them now, they continue to move away from the Sun in different directions. Pioneer 10 is headed roughly in the direction of the star Aldebaran, while Pioneer 11 is moving towards the constellation Sagittarius, meaning it is heading towards the center of the galaxy. Both carry messages to extraterrestrials, the famous Pioneer plaques. Similar ones were also placed on the Voyagers. By 1980, when the spacecraft had moved far enough from the Sun, it became clear that something was wrong. Something was slowing the spacecraft down. On Earth, we essentially can't launch a flying vehicle and make it fly forever. It will be slowed down by air friction and Earth's gravity. Even in low Earth orbit, satellites don't fly indefinitely, and although very slowly, they are slowed down by the atmosphere, which still exists at several hundred kilometers, albeit very thin. But far from the atmosphere and massive bodies in space, if we accelerate the spacecraft, it can travel for a very long time. Thanks to this, the Pioneers and Voyagers will continue to travel for tens of thousands of years and possibly much longer, without any additional engine burns. They have already accelerated, and the only thing that could slow them down is a collision with some object. Or they might be picked up by extraterrestrial beings? But that doesn't mean that their velocity does not change at all. They can still be slightly slowed down, for example, by external influences like cosmic dust or the gravitational pull of other bodies. Both scientists and engineers were aware of this, and the Pioneers did experience some slowdown, which in itself was expected. However, even considering all possible effects, such as the gravitational pull from known bodies, interactions with matter, and so on, there was still an additional effect that had no explanation. The spacecraft were slowing down more than expected, and this was indicated by the additional acceleration directed towards the Sun. In other words, in the direction opposite to the movement of the spacecraft. And this acceleration is approximately 8.74 plus minus 1.33 times 10 to the power of minus 10 meters per second squared. It might seem very small. However, considering the vast distances the spacecraft covered, Over the course of the year, a noticeable difference accumulated between the calculated and actual distance to the spacecraft, and they ended up thousands of kilometers closer to us than they should have been according to the calculations. And this small but measurable difference from the predicted values was a problem that needed to be explained, especially since the effect was observed in both spacecraft. What was slowing them down? An unknown object or objects in the solar system, or perhaps gravity actually works differently than we thought, which is why our calculations aren't entirely accurate. Interestingly, there have been examples in history of both the first and the second situations when explaining some observed anomaly. While observing Uranus and calculating its orbit, astronomers noticed that its behavior is slightly different from what was predicted by Newton's law of gravity. Among the possible explanations for Uranus' anomalous behavior was the presence of an undiscovered body beyond the planet's orbit that was affecting it. Or maybe gravity works differently at great distances than described by Newton's laws. Now we know that the correct answer was the first one, and this unknown body was Neptune, discovered later. With the influence of Neptune taken into account, everything more or less fell into place, and Newton's laws held strong. In the 19th century, decades of observations of Mercury allowed astronomers to measure the precession of its orbit. It turned out that perihelion of Mercury, the point of its orbit closest to the Sun, was shifting, which again in itself was not surprising. What was surprising is that the actual value differed from the one predicted by Newton's laws. The difference was small, only 43 arcseconds per century. But again, it was enough of a difference to be a problem. In this case, there was also an attempt to explain the discrepancy by the influence of an unknown planet Vulcan. However, the existence of an undiscovered planet in the inner solar system was much less likely. And as we now know, no planet Vulcan exists. To explain the discrepancy between theory and observation, a new theory of gravity had to be developed. The solution to the anomaly was found thanks to the emergence of Einstein's general theory of relativity, in which the motion of Mercury in its orbit was governed by the curvature of spacetime, and calculations based on the equations of general relativity provided exactly the value that matched the actual observations, thus solving the problem of the missing 43 arcseconds. In the case of the Pioneer anomaly, scientists faced a similar dilemma. Is the problem simply an unknown external influence, or is it our understanding of gravity? Although there were many possible solutions to the anomaly. By the way, how was it even possible to measure such a slight additional acceleration? Well, first of all, Doppler tracking. The spacecraft deep in the solar system transmits a radio signal of a known frequency to Earth, where it is received by a network of radio telescopes, the Deep Space Network, which both receives and transmits radio signals. Due to the Doppler effect, the frequency of the spacecraft moving relative to us changes. The wave stretches when the object is moving away and compresses when it is approaching. This is also referred to as redshift and blueshift respectively. Of course, there are many nuances involved, such as Doppler tracking can be one-way, two-way, or even three-way, but for now the key point is that by analyzing the signal from the spacecraft we can gather information about its movement. And in the case of the Pioneers, the unexpected blueshift, or acceleration towards the Sun, was precisely what was discovered. Perhaps some might have a question. It is called the Pioneer Anomaly. Well, it is clear that it was first discovered in this spacecraft. But if the effect is truly related to gravity behaving differently, or if it arises from some external influence, shouldn't we have detected this effect in other spacecraft as well? After the Pioneers, there were their successors, the Voyagers. Spacecraft also flew to Jupiter and Saturn. But the thing is, this effect was only confidently detected for the Pioneers. What set them apart from many other missions was that both spacecraft were stabilized by rotation. And that means, well, it means exactly that. They were made to rotate around a specific point, which allowed them to maintain a stable position. And thanks to this technique, the spacecraft required minimal course correction maneuvers. and this in turn allowed their acceleration to be measured with unprecedented accuracy using Doppler tracking. The Voyagers, on the other hand, were not stabilized by rotation. They relied on more frequent engine burns for course correction and orientation. As a result, the measurement uncertainty for their acceleration was higher than for the Pioneers. It would have been impossible to detect the effect in the Voyagers if it had been caused by external factors. As I already mentioned, there have been many attempts to explain the effect. We won't go into all of them in detail. Here is a long list from the review article by Vyacheslav Turyshev, whose efforts, by the way, ultimately helped solve the mystery. Perhaps the most mundane and boring reasons, the effect could have been caused by the spacecraft itself. A gas leak acting like an extra rocket engine and slowing the spacecraft down, or the effect could have been caused by asymmetric thermal radiation. External factors include the influence of interplanetary dust and the drag caused by it, or gravitational effects from unknown objects in the Kuiper belt. More extraordinary reasons could include effects from the influence of dark matter and even dark energy and the expansion of the universe. And the most exotic ideas suggested revisiting the current theory of gravity. One such idea was the use of MON theories, modified Newtonian dynamics, which some now consider as an alternative to dark matter. I talked about it in more detail in this video. But as I said, the anomaly is now considered solved, and I don't really remember any kind of revolution in physics or a major shift in our understanding of the universe structure because of the Pioneers. And all because the explanation turned out to be one of those mundane ones. However, the path to the answer was far from simple. It took many years. To get the answer, it was necessary to gather as much data as possible about the spacecraft flight. Nowadays, for modern missions, data can be found in digital format, even in online databases. Here, these missions lasted for decades, during which technologies and formats changed. The data was stored on various outdated media, including magnetic tapes. It was scattered across different institutions and storage facilities. Here, Vyacheslav Turyshev was helped by the Planetary Society in the search efforts. But in the end, the necessary data was collected. Analyzing the spacecraft data was also a challenging task. During the process, an important point was determined. If the cause of the anomaly had been something outside the spacecraft, the effect would have been constant. And early data suggested that this could be the case. However, a more detailed analysis of the data by Turyshev and his colleagues revealed that the effect actually changed over time. Specifically, it gradually weakened. This could indicate that the cause of the effect was within the spacecraft itself. For example, if the issue was related to thermal radiation, as the radioisotope thermoelectric generator weakened over time, the breaking effect would also diminish. Turyshev focused on thermal effects as the likely cause, and the obtained data allowed for the construction of a thermal model of the spacecraft, leading to the solution. We already established that the spacecraft were stabilized by rotation, and they were almost always oriented with their antenna pointed toward Earth. However, the sources of thermal radiation were located on what could be called the front-facing part of the spacecraft in the direction of movement. The thermal radiation from the RTGs did not radiate evenly in all directions, and also reflected off the rear side of the antenna and was emitted forward. And we know that radiation can also create thrust. Additionally, the front part of the spacecraft housed an electronics compartment, which also served as an additional source of thermal radiation. As a result, we have asymmetric radiation, and it essentially worked as an extra source of thrust, which ultimately slowed down both spacecraft. So, no new physics. However, as I said in the beginning, even after the publication of articles solving the mystery, there were still papers like this one, where it was suggested that the cause might still be new physics. However, the version proposed by Vyacheslav Turyshev is the most likely, and supported by real data collected over decades. Therefore, this anomaly is now considered solved. Not all anomalies manage to find a satisfactory solution though. A striking example is the so-called Flyby Anomaly, and it's strange. At first glance, the story here seems similar to the Pioneer Anomaly. The essence of it is that the observed speed of the spacecraft differs from the speed predicted based on calculations considering known physical laws and current theories. However, in reality, the situation here is quite different from the Pioneer case. Why is the anomaly called the Flyby Anomaly? Well, because it is observed during flybys, or precisely after performing gravity assist maneuvers. Gravity assists are quite common in space exploration. They allow a spacecraft to reach its destination faster and/or more efficiently by using the gravity of a planet. By launching the spacecraft along a specific trajectory, we can make it fly close to a planet, which will accelerate it with its gravity or, conversely, slow it down if needed. I talked about how this works in more detail in my video about interplanetary travel. Be sure to check it out if you haven't seen it yet. For example, the Voyagers mentioned today performed gravity assists at Jupiter and Saturn. Earth's gravity is also used to perform such maneuvers. Here, for example, is the trajectory of the Galileo spacecraft, which studied Jupiter and its system. To reach its destination, it performed a flyby and a gravity assist near Earth in 1990. I mentioned the Galileo spacecraft for a reason. It was during its flyby of Earth the anomaly was first discovered. The spacecraft performed its maneuver, and Doppler tracking measurements showed that after the flyby, its velocity was higher than predicted by calculations. Not by much, but still higher, by about 4 mm per second. Although this is a small value, it is still more significant than in the case of the Pioneers. This means the discrepancy could be measured even for spacecraft that were not spin-stabilized. The anomaly was also observed during other missions. The NEAR spacecraft experienced the largest unexpected acceleration in 1998 by about 13 mm per second. A similar but weaker effect was also measured during the flybys of the Rosetta and Cassini spacecraft. This at least shows that the anomaly is not due to the design of a specific spacecraft, since it was observed in multiple missions. But things get even trickier from here. All the flybys I mentioned occurred near Earth. Could something be off with our planet? But here's something even more interesting. Galileo spacecraft performed not one, but 2 gravity assists near Earth. And during the second flyby, no anomaly was observed, and everything proceeded exactly as calculated. The same goes for Rosetta. During its second and third flybys, no anomaly was observed. Or perhaps during repeat flybys, the effect was so weak that it fell below the minimum threshold at which it could be measured. So we have some kind of anomaly that affects different spacecraft, and it specifically occurs during gravity assists near Earth, and on top of that, the effect appears sometimes and disappears at other times. But at the very least, the effect is noticeable enough to be measured, and it's significant enough to be a problem. As with previous cases, this could point to something we still don't fully understand, but what particularly puzzled scientists and engineers was the illusionary nature of the effect. Why does it appear sometimes and not at other times? As with Pioneers, a large number of possible explanations were proposed. Among the more mundane explanations were simply issues with the equipment and measurements. Some suggest that there was no additional acceleration. It was just a measurement error. There was also ideas related to the Earth itself. The spacecraft fly by the planet, but the distribution of mass within the planet is not uniform, and on top of that, the Earth itself is not a perfect sphere, but slightly flattened at the poles. Could it be that when the spacecraft flew by from different sides of the planet, they experienced slightly different gravitational pulls? They also found some correlation between when the effect was observed and the orientation of the spacecraft trajectory during the flyby relative to the planet's equator. And could relativistic effects be at play here? The Earth, with its mass and rotation, might be twisting space-time itself, which could give the spacecraft additional velocity. They also tried using a model with a dark matter halo around Earth, various unknown forces, hypothetical gravitomagnetic fields, extensions of general relativity, but it seems that even in works with the most speculative ideas, they couldn't fully explain this effect. And this strange acceleration of spacecraft near Earth remains a mystery to this day. Potentially, a solution could be found by spacecraft specifically designed to study this effect. But unfortunately, none have been launched yet. However, it is possible that in the future, this mystery will also be solved, just like the Pioneer anomaly was. In 2021, something strange began happening with the most distant man-made object, Voyager 1, which is currently over 25 billion kilometers or 15.5 billion miles away from the Sun. At first, the cause of the anomaly wasn't known and it wasn't clear whether the problem could be solved. However, later both the cause has been found and the problem has been solved. The story caused quite a stir at the time. A spacecraft, which by some criteria is already in the interstellar space, is sending strange signals. What or who is doing something to it? Even NASA's press release sounded quite mysterious, and I quote, "The data may appear to be randomly generated or does not reflect any possible state the ASCS could be in." Oh, but what was happening with Voyager? There was some sort of malfunction with the spacecraft attitude and articulation control subsystem. As the name suggests, it controls the spacecraft orientation in space, which is undoubtedly important. For example, it is crucial for maintaining communication with Earth, as the spacecraft's antenna needs to be directed towards us in order for communication to be possible. Overall, the spacecraft was functioning normally, carrying out commands and sending scientific data, but the attitude control system was not reflecting what was happening on board and was sending back nonsense. What's even more interesting is that the protective systems did not activate during the malfunction, which would usually send the spacecraft into safe mode until the issue is resolved. So what was going on? Was it caught in some strange spatial anomaly, or are these guys at it again? For some time, there was no answer. Now, however, it has been found. It turned out that the system was actually sending normal data, but for some reason, this data suddenly started passing through the wrong computer. It was going through a computer that had stopped working properly many years ago. As a result, the data got corrupted, and all that was sent back to Earth was nonsense. The engineers working on the mission were able to send a command to the spacecraft to switch to another computer, and everything began functioning normally. The only remaining mystery is what caused the orientation system to suddenly switch to the broken computer. However, it is likely that the answer will be found after a thorough analysis of the data. Once again, it wasn't the work of aliens or new physics with spatial anomalies. Meanwhile, the spacecraft, which has been flying for over 47 years, continues to function normally with 3 instruments still operational. When scientists and engineers work on a mission for many years, sometimes even decades, one of their biggest fears is that something will go wrong. But as it sometimes goes, unexpected data and results can be even more interesting than the predicted ones, as they can reveal something new about the universe.